Now we're moving into some fancy C++ 23 territory.
Yeah, I absolutely hate this.
It's not very
With
evident
a
unless you read the documentation what the heck's going on
with a
here.
burning fashion. And to be honest, this is one of the things that I haven't seen in my life done in any code like that.
All right, guys, CJ here. Today we are going to be reviewing the code of a Discord member of mine by the name of Quasar. I'm here with my mentor, KJ, who is going to be reviewing this with me. We're going to start by looking at the vector implementations tests, and then we're going to slowly work our way through the vector implementation. So without further ado, KJ, let's start at the beginning of the tests here.
The thing that gets my eye here is that you have to remember about resetting your counters, which maybe isn't ideal if you get someone new here. I would probably go with something smaller, like local class that counts stuff. So there, whenever I would need counting, I would create a local variable of it and use it in some way. It's very odd because if you take a look, expect equal size equals 5 is true. That's a little bit intriguing. Why not just and the same with greater than 0, expect this to be true. So you would have, I don't remember exactly which part is the expected, which is the actual, but that's maybe less important. But there's also like expect greater than, greater or equal. So it's, if I recall correctly, it's expected GT. But I wouldn't, give my finger for
Right.
that. But I do know that there are specific functions for that, and I would definitely use them. And there's also an interesting option because you can use the shift operator to stream in an additional information. So after the closing parentheses, you can go like shift left and add a message and explain what is expected and why. So that's definitely something that would be rather helpful. I would probably separate this into two different tests so that they check two specific things.
So you're saying that you would have a test for the second half of these, and then a
Yeah, it
test for
would
the
be
first half.
separate.
Okay. Looks quite similar, and we're also testing two things. So here we're assuming, or we're testing that we have 10 items that are each 5.5.
Right. So 86 line, it seems it's redundant, right?
Right, because we have the...
And what I would do here is I would test all of these values, not
Yeah.
just the first one.
Yeah, I remember when I was implementing vector or list, I forget, and we were going over my tests, I was doing the same thing where I was assuming that because the first item is initialized correctly, that, oh, the other ones are for sure too. But then we realized that, oh, wait, one of them's missing or something, or one of them isn't
Yeah.
there. So,
What I would do here, imagine a situation where you have a bug with the initialization list and line 101 just creates an empty vector. So we will have the same size and all of the elements that we check from 0 to size are going to not be different because there's no elements, right? So I would say definitely instead of checking these two sizes to be equal, you can save it, keep it like that because that's a valid check. But also I would separately check if the size is what I expect, which would be 5 items.
right, because
Um,
that might be an interesting bug where you expect 5, but they're both 3.
for example, yeah.
But
Or
you never
maybe they
check
are
for the
both
3.
empty.
Yeah. Here's a move test. And just immediately I noticed the same issue here in terms of not checking all elements in the vector,
Right.
because you want to make sure that the other two were indeed moved correctly. And it looks like what he
Yeah,
did well
exactly.
here is he's also keeping, I'm not sure if that's the right way to put it, but he's, the V1 that has been moved from, it's placed in a functional state after it's been moved from. He doesn't need to in theory, but he's adding additional guarantees that the size will be 0 and the capacity will be 0. So we're able to learn from these tests what the expected behavior if I moved from vector that he implemented is, which is nice.
Right. Yeah, I like this a lot. And here's what got me a little bit surprised, because here the style of these asserts, the expected equality, they are different. They are by the book. So it makes me puzzle why they are sometimes done like this and sometimes like
with true.
with true, right?
Yeah.
Yeah, so we should check for a specific size as well over here.
Yep. So we have that error bound condition.
That's a good test. That's a good test here.
I would also be interested to see this. Unless this is implemented as size t. Yeah. Well, he does have a check for less than 0, but that's what I effectively wanted to check for. Yeah, in this case it's size t, but it doesn't. I don't think it would hurt to add a negative out of bounds check in case that size type was not unsigned.
Right. You can leave it at that and just leave a comment.
Yeah.
That you want to know what happens if you give it -1. Because that is possible, right?
Yeah.
There's nothing stopping you from hitting a -1 over there. And this could actually happen not as giving -1 exactly, but you can do some... We shouldn't, but we can do some manipulation on indices. We can make a mistake over there and end up having a negative index.
Yeah.
As a result. I would add a test, because I'm pretty sure there's like a clear or something like that. So I would then clear the vector and check if it's empty again.
Yeah. I'm actually not sure if he implemented clear though. I don't recall seeing a clear.
If it's not there, then it's missing, right? Because you definitely want something like that.
Yep. I like this. What I don't like about it is it doesn't test that 1, 2, and 3 are still in there.
Right. There's actually quite an interesting thing, which I think shouldn't be here. It's unexpected. Like if you're using standard tools, at least it's unexpected way for this to behave, because if you resize, you don't exactly want those default values, because depending on your system, these can mean something in your system, and if they mean something important, like for example, if they by default will reserve some resources, and you reserve like 1,000 of them, you get 998 default constructed items. If they construct something like a database connection, you may run out,
right?
And you can kill your system like this.
Would you then recommend that, given that reality with certain objects, that Resize would maybe have an overload for a second parameter that takes in the type of object to construct as opposed to being the default constructed object? So maybe you might pass like a dummy database object that doesn't initialize anything on construction.
I just wouldn't implement it like it.
Interesting.
Like this in the first place.
Okay. Pushback. Okay, this seems quite simple. 3 items, ensure that there are 3 in there, and they're all these 3. And now we get, boom, a wall of text. Okay, so what's this? The design of pushback insert is slightly hard to get right. If the vector is full, and you reallocate the vector right in the beginning, then the value of pushback becomes a dangling reference if it refers to old storage, an element of the vector itself. Oh, if it refers to an element of the vector itself. This test is meant for such edge cases.
What?
I think what he means is if you do something like auto reference back equals vec back, And then later on you push back, which causes a reallocation, then cannot refer to back anymore since it's a dangling reference to now deallocated memory. Does that make sense? But I'm not sure what... That wasn't clearly communicated to me, I think. And I'm not sure how that tests this, so let me see what he means here.
Yeah, that's very interesting. I don't think I have ever seen in my life, and including, the university times where we all did crazy stuff with code, I have never seen once a vector pushing back its last element like this. That's what I'm puzzled by this. It definitely would require much more digging.
And the comment is leaving me with a question as to whether or not I understood. For popback, so I did a cursory review of the vector implementation, and I know for sure popback does have a bug, and it's interesting because this doesn't actually catch it. Well, I guess when we look at vector, we'll take a look at popback, and the bug is quite evident, but the bug manifests in 3 never actually being deleted. So
Right. And the test does not check it because int is not going to scream nor count about, do accounting about how if the destructor was called or not.
Exactly, yeah. Because what he's doing here is he's checking that 1 and 2 are fine. That popback didn't have a side effect on 1 or 2, but he's not directly testing that 3 doesn't exist here anymore.
Make a small class that's going to somehow, write about it, and then you know for sure.
I see, okay.
We can probably get the existing class already, right?
Right, the AllocCounter.
Yeah, and use it over here.
Okay.
Yeah, I'm not a big fan of in-place back.
Why is that?
Like, I would actually have to have a proven scenario where this helps in performance in a meaningful way.
Okay.
And if you see in-place back 1, 2, pretend you don't see line 274. What do you think does it do? Because I have no idea. So especially when names are like V and it's not points, for example, there's no way for you to just look at this line and know what's happening.
I think there will be some people that might disagree with you about the in-place back, but...
I'm going to put it this way. Everyone carries the costs of making their own decision. From my example, one of the heaviest costs is unreadable code. So where you have to second guess because 9 out of 10 times someone is going to just check. And 1 out of 10 times someone is going to be like, well, I think I know or I remember, but they may remember wrong because code might have changed by the time they last time look at it, or maybe they can guess it wrong. And then if it's a tricky case, which happens sometimes, you're going to have a problem on production because tricky things have a tendency to not show up when you're testing.
Manifest at the worst times.
But yeah, if it's something very heavy and you can prove, that is the most important thing. You need to prove that it optimizes something. Don't wing it, never. There's one thing that caught my eye.
Okay.
Insert having overloads. I don't really like it all that much. Because inserting at a specific spot, okay, I get it. I would call it insert at.
At, right.
But later on, we have this insert that takes range.
Yep.
But on the other hand, it's just beginning end. It's most probably a range, but you don't know. And since this has to have a comment above it, it should be in the name. So it should be insert range, in my opinion.
All right, let's jump to vector here. I'll start at the very top. I know that there was iterator, but if we can spend a whole hour probably just on iterator. So I figured we can start at vector if that works with you.
Yeah, I would omit the iterator because the iterator it's very hard to mismanage it.
Right.
Private stuff is of secondary interest. It's I remember this still from the times of university. The professor that was teaching us C++, he told us a very smart thing about this. Private goes to the bottom of the class because when someone is looking at your class, his first interest is the public interface.
Yeah.
I would put everything that is private on the bottom, and I actually hold to this rule with my code. And definitely this should be a constant method, right?
Yes,
It
that
doesn't
is
change
true.
anything.
That is true.
And now this card is a nice touch.
Yep, I like that too, using those attributes.
Reserve capacity, and if it's 0, give 16. If it's not 0, double it. That's an interesting thing because different compilers do it differently.
Yep.
Most do ×2, but for example, Microsoft's
1.5,
does
right?
plus 50%, yeah.
Yeah.
But a minimum of 1. And the smallest, if I recall correctly, like some of the compilers actually allow you to have a capacity of 1. So there's like a 1 item on the heap. Here, giving it 16 has to have an explanation, and 16 can be, well, maybe we should start from this. Why are you writing the vector? And here, obviously, the answer is because I want to know the language better, and I have to practice. But what else you need to ask yourself when you're going to, because this is, I guess, the first, maybe second implementation of the vector. If you want to practice, it's a great idea, and you probably should have 10 different attempts on this and do different versions and approaches. And when you do it, ask yourself, why are you creating this vector instead of using the standard? And the answer is because you need something that the standard does not give you. So maybe it's going to be kind of like a small buffer optimization. And the reason why you wouldn't get 16 elements up front, imagine you have heavy items over here. And heavy items tend to not be high in count because you can't just freely, let's say something takes 5 megabytes. You're not going to just freely get a million of them. So if you're only going to use 2 or 3 of them, you don't want space for another 13 to just be wasted out, right?
Yeah, that makes sense, especially with memory sensitive systems where there's memory constraints, like embedded devices or something.
Right.
Yeah, what do you think about maybe a bit less of a, when you did talk about like the 16 where it comes from, but whenever I see a number that doesn't have a name associated with it, just like a number in the ether, a magic number, I get kind of weary. I don't know what you think. Like, do you think it's worth having a name that describes the reason for 16? Like something a little more descriptive, like why was 16 chosen? Why not 4 or what, like you said, 1 or 8? I don't know.
Right. So definitely a good idea. What I would do is I would give capacity equal, or maybe if capacity is greater than 0, double it. So I would not do, and I never do, I don't do ifs, I don't do while, I don't use the ternary operator, and I don't cast to bool implicitly.
Oh, so okay, I see what you're saying. You'd say if capacity is greater than 0,
Yeah,
then just times it by 2?
exactly.
Otherwise, okay. And is that just for
easy.
like clarity?
Yeah, exactly.
Okay.
It's easier to read, hard to make a mistake.
Okay. Cool. Clean up on fail AUX auxiliary?
Probably, yeah.
Okay. When I was looking at this, so there's there's three things here that immediately piqued my mind. So one is the use of destroy out, which is nice. I think that's C++20. So that is similar to calling the destructor of the object that's located at this memory address instead of calling it by typing it out with the strudel character or whatever. It's a bit more, it's a bit clear what's going on. Is it overkill to call operator delete, like to specify that this delete comes from the global scope?
Probably not only overkill, but you can probably make a system not work. Imagine that you have a buffer that is pre-allocated and you want your items in that area of memory only.
Okay.
And then you have new and delete operators to use this block of memory by default.
Mm-hmm.
You can't, when using this vector, you can't really use this new and delete. It's not going to call the delete that you have for this specific item type, because the way you will do it, you would put some additional work into these calls so that they just would automatically use it.
Does that require that for that pre-allocated array that somebody overrides the default implementation of delete, like in the global namespace, they define delete there?
Yeah, like
Okay.
for a specific type even you can do it.
Right.
And
Okay.
here that's not done very often.
Right.
But definitely someone would be scratching their head. So
Seriously?
I'll personally get the regular delete. And if you really want to have this, I would probably get like an additional template argument for the vector and implement it like a policy. So you would have a delete policy that you will force the default implementation, and then that could be picked if someone needed it. But in all other cases, it would just call the regular delete.
Okay. So you'd have like a specialization for a given policy?
Yeah.
Okay. And then the third thing that piqued my interest was I actually ended up adding a question to getcracked.io as a result of seeing this line 260. So it just says throw. Now, I asked myself, well, what happens if an exception currently isn't being propagated and an intern sees cleanup fail auxiliary and calls this outside of a catch block? Like, what is that? What does that do? Like a random throw when there's no exception.
It calls terminate. I've checked that because that was when I looked at that code. That was the first thing that looked like a point of interest.
Yeah, exactly. And then I read that it's actually undefined behavior, but most implementations will call terminate. So what do you think about that? So this is only ever used, just to give him credit, it's only ever used correctly, so in a catch block. But still, like, is it bad practice to have this here? Sorry.
Yeah, like if something can cause a failure like this that is unconditional, I would probably not do it like this.
Yeah.
And we can move to the next one.
Okay.
And I would do it over here, right?
Yeah.
I would catch STD exception by reference.
Right.
And then you can refrow it from here. And to be honest, this is one of the things that I haven't seen in my life done in any code like that, right?
When you say like that, you're saying you've never seen the throw?
No, I've never seen just banking on how to say it, on order of function invocation to make exception handling work as someone thought about it, right?
As in, an exception will always be in the process of being propagated while we call cleanup fail auxiliary.
Yeah. So because what I expect the intention was is to refrow the exception that happens inside of the cleanup on the fail, right?
Yeah. But there is no catch here.
Yeah, so I'd just make a catch and rethrow something.
Right.
And again, I would just I wouldn't catch 3 dots because what does that mean? You can't even log what happened.
Right. That's true.
So I would definitely catch it as a reference to the STD exception and then do something with it, either rethrow it
Log it and do whatever you need
or
to.
log it, right?
Yeah.
So that may be another reason why you are making a vector of your own, because you want this to be logged or something like that.
Do you want to do copy range?
Sure.
Here he's using C++ 20 concepts, so he's ensuring that iterator is of type forward iterator.
Right. You can just put these concepts in the
In
template
here.
definition.
Yeah.
Don't have to use static assert in that case, and it's probably what I would do. Because I would, when I'm looking at this stuff, I expect the concepts to either be attached to the types, so
Yep.
in the argument list, though I personally prefer them to be like in those requires clause in the template definition, because then I can see, okay, this thing is required to have this concept.
Yep.
And when I see static assert, um, I think twice of what's happening over here, because you don't have to actually give an actual concept to a static assert, right?
Yep. That makes sense. So it's saying copy the range. So from the beginning, oh no, sorry, from the first element, construct at the ith location. So from the beginning of the vector. So from whatever range, just start placing it at the beginning of the vector.
Yeah, so first thing that I'm going to point out is these names are not helpful.
Yeah. What do you think about the notion that if one of these constructions fail, let's say one of these objects that are being constructed, let's say the last one in this range, so last, or one before last rather, is being constructed at location I, then cleanup on fail will destroy every item in the vector. Oh, it will destroy up to I, which in that case will be it'll be everything before the item that failed. So if the ith item fails, everything before it gets destroyed.
The item is in improper state right now, right?
Yeah.
So if we call destruction on it, the algorithm that destroys the item assumes it's in proper state. So if we have it in corrupted state, we can crash on that or get undefined behavior. I would say that I would expect that if I want 100 items copied, then I want 100. And if 80 were copied and then something wrong happened, to me, the operation failed. Right? Because if you're going to read some code and it's going to say, I'm copying all of these items, then all of them have to be copied.
Right.
The thing that I am worried about here is the copy will not happen, but then you won't inform the user about it, right?
Yeah, that's true. So they'll be under the expectation that they have 100 or whatever first to last is, starting at the beginning of the vector.
Yeah.
But they don't anymore.
They don't exactly. And also,
I know that when we did speak before, you had a problem with allocate auxiliary, and I don't think my problem with it was the same one that you had. I'll start and then you can continue as well. For me, I was kind of confused why in general std allocator wasn't used, or it wasn't like there was no option to template an allocator, where std allocator might be the default allocator. Every time I've implemented a vector, it's always been easier to just have a std allocator to do .deallocate or .allocate. To me, that's simpler than, and is much more descriptive than the operator new size of this times this pointer cast. I don't know. To me, it's just a little easier.
So I don't like it for the following reason. If you're going to cast it to a pointer, just use the type of element. Because look how complicated this is. When I look at this at the first instant, I thought to myself, Yeah, it's probably this byte-wise way of allocating things. But if you take a closer look, it is just allocating the pointer to the type, just right, new t and the capacity, or maybe element type or element, whatever is used over here, because it does the same exact thing, but here it's done manually, right?
Yeah.
And you probably want to return it without assigning it to a variable. Although there is a case that excuses the existence of the variable, and that is if you want to have it for debug information, because it's going to be optimized that way in a release build. Anyway,
Copy old storage to new. I don't like this name, empty. I hate it on vector because I'm always confused. Does this like if I'm a new person to C++, I see empty. Does that mean clear, or is it like
yeah, I actually that is me from a good 18 years ago when I first saw that. I was like, okay, I don't want to empty my collection. I just want to
right,
see if it has elements.
right?
Yeah, but that's something that I've mentioned uh, earlier, and it's all about naming convention. I would never go for this empty and that's it. I would say what question is answered here. So I would say is empty
Yeah, or has elements or something.
or has elements. But here it would be is empty because this is what the function is checking.
Yeah.
Size, capacity, these are standard for vector classes, but there is definitely good reasons to just name these get size, get capacity, because that's what you're doing. You're just getting a number that already exists.
Yeah. I'm confused why this is. Maybe I'm not seeing something. Like, why can't you just do n here? Maybe if it's copy auxiliary fails? Yeah, but let's say it does fail. And this throws an exception. It'll catch it. It'll clean up everything, so the size will in theory be 0. Because it deletes everything until the last, which is the one that it was working on when the exception was thrown. And then it'll still set size to n. So in my opinion, that's a mistake.
Yeah, that's probably a bug because the exception is not propagated outside, right?
Yeah. It's just caught and swallowed.
Yeah.
Swapping the elements, sizes, and capacities.
Yeah. To be honest, I don't remember when I would ever use swap name vector, but maybe one day.
I've never used it either. It is, though, used here for the copy and swap idiom. What he's doing for the operator equals internally is he's saying, take this other vector, copy it with the copy constructor, and then replace my contents with its contents and return my
So
stuff.
first of all, I would check if we're trying to copy to ourselves.
Right.
The question is, what happens if we try to copy to ourselves this way? I guess we just lose time. It's a style thing. I think that getting parentheses over the start is absolutely redundant in a return statement. So I would never put them in. It's cloud that probably doesn't do.
So you're saying do this.
Yeah, I like that more. But then if you take a look at 417,
Oh, this, yeah.
this is in parentheses.
I was confused. I'm like, is he trying to do something like super fancy that I'm not sure? Like adding parentheses changes this or something? Then I'm like, no, it doesn't.
Yeah, it doesn't, so just don't put them, right?
Yeah.
Assigning from initializer list.
Can't you code it relative to this? Like, can't I just do vector and then just pass in this? Like, it's going to call this.
No, but we're assigning to ourselves in here, right?
Oh, right. Well, I can do this and then I can just do what he did before. Can't I just do the swap with this?
I don't know. I don't like it. a lot.
Okay. Oh, you don't like coding the assignment operator against initializer list?
No, I mean that too. I don't think I have never used that in my life.
Like the assignment to initializer list? Me neither.
Yeah,
Yeah.
rather from an initializer
From
list
an
in this
initializer
case,
list,
right?
yes, yeah.
And I don't like using this copy swap thing,
That's valid, okay.
but that it's not a hill that I'm going to die on, right?
Right.
So if it's important for someone to use it, be my guest, but I just wouldn't code it like this.
Mm-hmm.
Like there are many places where we're using raw pointers anywhere, and raw pointers are frowned upon for a good reason, but you can just listen to what Strustrup says. You don't want to see new delete. You don't want to see any raw pointers outside of your abstraction. So if you're going to work with memory, like we're working here, I think it's justified to just use pointers.
And then, like I said before, this is the same thing here, and it's called a lot of different times.
Yeah. So I was gonna say, a clear method. It's
Yeah.
just like chef's kiss perfect for
Yeah.
for the needs of this class.
Yeah. And then it was just set the size and capacity to 0. Now we're moving into some fancy C++23 territory.
Yeah, I absolutely hate this.
It's not very
With
evident
a
unless you read the documentation what the heck's going on
with a
here.
burning fashion. Okay, so let's unpack this. There's a simpler way to do it. Just get two overloads,
Yeah.
one for const, second for non-const. Second of all, like you already have a way to pass this. Just have it in a class and it's passed for you, right?
Mm-hmm.
Yeah, you have to use magic instead of using a single word to add the const on the function. You have to use spells. You have to, if const expert, then check something from traits, then remove the reference, use decltype. This is very, like, it's so much text that does nothing,
Yeah.
right?
It does nothing
But
for
when
the
you do
reader,
it,
yeah.
yeah, when you do it like, and on top of it, it's a non-standard way to do it. So it carries all of these bad things around it. But the way you pasted it here, simple, standard, easy on the eye. This is something that Strustrup said in, I think it was a lecture from him from 2025, actually, so from this year. There are a lot of features in C++, but they aren't there for you to use all of them. So this auto ampersand self, if you have to make a recurrent lambda, which you shouldn't do, use it there because it's nice.
Without the this, it's abbreviated function template syntax, which that's C++
Yeah.
20. But when with this, that's C++ 23, and it's consider the CV reference qualifiers for this when generating the function that's called for begin. It might generate it with the ampersand here, or if it's like an R, if you're calling begin on an R value of vector, then it'll generate this overload of it. So yeah.
Yeah. It's not only like we're going to say bad things about it, because there's an intention over this, and the intention is to do something robust and to keep an eye on all possibilities.
Mm-hmm.
So what may be a good idea is to have a separate implementation when we are calling on a copy. And then maybe we don't want to have these functions and just mark them as deleted. Right?
Right. So you're saying something like, I don't know.
Yeah.
Equals
Delete, right?
Okay.
And same for the const version.
Yeah.
And it's a detail, but one day it may save you from a week-long investigation.
Yeah.
And if that investigation happens to, be related to production directly, that 1 week can be a lot of money.
Yeah. See begin, very simple, very clear. Exactly what we were talking about in terms
Yeah.
of clarity. And he kind of used the same magic there.
Yeah,
Let's
so the
see.
comment would be exactly the same over here.
Yep. Okay. Very clear in my opinion. I don't think anything here is worth adding unless you think differently.
Isn't at a const?
He has an overload.
Oh, great.
Yeah. Front. So this is an inconsistency because what he's doing here is the exact same like C++ 23 magic that he did up here, but like here there's just with an extra step. Like this is equivalent to this, so I don't know why he did it that way.
Yeah, so that would again, transparency. I don't use it. I don't know the small details about it, but this would suggest it's a template, right?
Yeah,
Yeah.
which is weird. Like why not just do?
Yeah, but you don't need auto.
Yeah,
That's
you don't. No, you
that's
just
another
use
thing.
you just use const reference.
Yeah.
Or sorry, or reference, my bad.
Or reference maybe. Yeah, I also don't. Do you really need decltype here? If you use auto, it should probably work, or you just write auto ampersand.
I think yeah, you just need to write auto ampersand because the auto won't deduce the reference, but decltype I think it will.
Yeah. So this is redundant. I would never
Yeah.
do such a simple thing. We would like to say m elements of 0 probably.
Yes. Sorry, I wasn't
in this
fully paying attention. Now we get to the fun part. Pushback.
Yeah, so we have an attempt on perfect forwarding here.
Yeah.
Pointer P, we will never know what that is. It's buffer, but is it used outside the if?
No, it's not. It's not.
Yeah, so it should be inside the
yeah.
if statement, definitely, and it actually should be where we're using the allocate, right?
Yes.
You can see that it's initialized with this. And now you can use the brackets initialization here instead of equals.
Yeah.
So here I'm actually a strong advocate about using this kind of initialization type, but not always. I still prefer if something is calling a constructor, I like the regular braces.
Okay.
So like the parentheses to signify that this is a constructor, and now you know it 100%, and you will never mistake it for initialization from a specific value, and you will never mistake it for initialization from an initializer list.
Yeah. Something that's interesting that I noticed just now is like this is the same code that we saw previously for grow.
Yeah.
But it's subject to the fact that if somebody changes this to 8 here and it's still 16 up there, then they might miss that.
Yeah, it's an inconsistency, maybe a bug. So yeah, as I said before, like we will see this exact same code again. So there's a lot of stuff being just repeated here.
Yeah, this is also, I mean, the same thing in both ifs. It's a very small change, but nonetheless.
Yeah,
do that.
It's a good change, positive one.
This is what looks like the most innocuous, simple code, but it's actually has a bug.
Yeah, I see it.
Yeah, so, and that's what wasn't being tested prior.
Yeah. Instead of using it like this, you can decrement the size and then just destroy at end.
Oh, right.
Yeah, and it kind of how to say it? It fits into what end means and what this function would do.
Yeah.
Because we decrease size, and the new value of end is the new last element.
Right.
So the previous to last before, and end points at the one that needs to be destroyed.
Resize. So if the current size is the same, do nothing. If it's less, destroy items. And
Yeah, I would
then
never do that.
if we have more than the capacity we're asking for, reserve the additional space, and then default construct.
Oh, I think now I understand why the global byte by byte kind of allocation of memory happened.
Why is that?
Maybe it was to eliminate the need of having a default constructor, but then resize forces it again. So not sure what was the actual intention there,
Oh,
but these two kind of contradict themselves.
right, because the byte by byte, as opposed to the T array with the size, would not require the default constructor, whereas T array size
Exactly.
would.
Yeah.
But then here we're still calling the default constructor on value type.
Yeah. Like, and the standard implementation has a pointer to void. I personally, when I was writing my training implementations, I was using byte t pointer, just to signify that it's a buffer of bytes.
As in std byte?
Yeah.
Okay. This is, oh, what I did not like here is, I don't know why this pause was named with an underscore at the end. I thought it was a private member variable for a second.
Yeah, so that's a good point because some conventions, I think Google has it, that you have the underscore at the end of a field of a class.
Yeah.
So that would be quite troubling when reading code.
It's a nice use of move backwards, in my opinion.
Right. Although I would just use, we already have a pushback function, right?
I see what you're saying, yeah. So you just iteratively push back the items that need to between pause and end, including the last
Probably,
item
yeah.
that was moved to the end. If you were to rate this one on a scale from 1 to 10, where 5 is average, and let's say this was his first go, maybe he edited a couple of times, what would you give it?
You know, I also would need something about the experience of
Of the candidate,
the
right?
person.
Yeah.
Because, for example, if a senior engineer brings this to me, I'm saying a good 2, maybe 3 out of 10.
Okay.
But if an like an intern or a student comes with this code to me, I'm going to say that's great effort, and it's a good. You can think of it like a good 6 out of 10 if this is your experience, and then let's talk what can be done differently, right?
Right.
What can you do to make it a 10 out of 10 with your experience?
Right. Okay.
Maybe one last comment though.
Sure. Sure.
To the author of the code, if you're watching this, don't get discouraged by seeing that there's a lot of comments for different parts of your code. That's the best possible way to grow as a programmer. And just do what you're doing, improve, repeat, and you're good to go.